Hello, this video is entitled Binomial Distribution from section 4.2 in the Larson book. Now, the binomial distribution is a discrete probability distribution that satisfies the following criteria. So it's a special type of that case. There are several other special cases, but we're not studying probability distributions at length in this class, but there are several others like geometric, multinomial, Poisson. But we're going to only study the binomial, which makes sense because it's the most commonly used. So let's look at the conditions of this experiment. Binomial consists of n identical trials. N is however many times. So if you flip a coin 20 times or roll a single die 12 times, that would be your n. Now, here's where it gets a little different. Each trial results in two possible outcomes called success or failure. For example, if we're rolling a single die and we're rolling, let's say, we deem whatever we want to be a success. Of course, actually, though, the problem will tell us what we're saying is a success. But anyway, let's say you know 2 is your lucky number and you want that to be a success. If it's not a 2, we don't care what it is. In other words, we're either saying 2 or not 2. So you have a 1 out of 6 chance it's going to be a 2, then you have a 5 out of 6 chance it'll be something other than a 2. So only 2 outcomes. We don't care about anything else, just these 2. That kind of trims it down a little bit here. Now, the probability of success on any one given trial is denoted by lowercase p. Capital P is the variable we use for probability, just like the probability of a certain number of successes. And Q is the letter they use for probability of failure, and Q, because it's the complement of P, is just 1 minus P. So that's what the Q just represents, the complements of each other, success and failure. The trials are independent and have nothing to do with each other. So let's say, for example, a single die is rolled 30 times, identify N, P, and Q, and we're saying a 3 or 4 is considered a success. So we're allowing 2 things to be a success. That's fine. There's nothing wrong with that. So either we get a 3 or 4, or we don't get a 3 or 4. Nothing else matters. So your N is 30 for the number of times you're doing this. Now, don't let this 30 affect your decision on what P and Q are. Now, all this is going to work together when we're doing the binomial probabilities, but for now, the lowercase p is always the probability of success on one trial, no matter how many trials you're doing. So you got 2 successes here, a 3 or a 4, so you got a 2 out of 6 chance of a success. And your failure then would be 1 minus 2 over 6, 4 over 6 reduces to 2/3. So as reduced fractions, they are 1/3 and 2/3. It doesn't matter whether we did this 30 times, 300 times, or 3,000 times. That would be the P and Q right there. Now here are some binomial experiments, flipping coins, rolling dice, and a lot of times the problem will say, even if you're not sure, it'll say, just assume the conditions of a binomial experiment are met. So sometimes we do take liberties with things a little bit, but now drawing cards, I'm mentioning here, drawing cards can only be considered binomial if you replace the card. Meaning, because if you didn't, your next event would be, the probability would be affected by the event before. Other things would not be, like rolling dice or flipping coins, or let's say we'll talk about this in a little bit, if you were guessing questions on a multiple choice and assuming test, and you're assuming that one question does not depend upon the other. So that would be binomial. Okay, here's the formula, which you're not going to need. Both Excel and the calculator have a formula to do this. So I won't worry too much about going into that formula. You see I have it right here. I have it over to the right. Just leave that there. If you're interested, that's fine. If you're not, that's fine too. So Let's look at the calculator. Looks like I did Excel first on this example, so no problem. Got to open up a spreadsheet here. Unlike the probability distribution, the general probability distributions from the last section, which didn't really have a convenient Excel command, we had to sort of program it ourselves. There is a built-in binomial function in the Excel, so that's good to know. So we're saying n is 2, n is 10, I'm sorry, x is 2. Oh, okay, let me talk about, the x is the number. So that's what we're trying to do on these binomial probabilities. I left that part out here. But I didn't want to leave this statement out right here. Is we're trying to figure out what's the probability we get a certain number of successes in those n trials. Okay, so I left that part out. I'm glad I caught it. So, and there's the formula for that. And NP and X are the key variables. Of course, like I said, Q is in there, but remember, Q is always just 1 minus P. It's not a separate number you have to come up with or have to know. As long as you know P, you got Q. N is 10, 2 is for X, P is 1/3. So this means you got a probability of 1/3 of being successful on any one trial. And if you do this 10 times, then what's the probability of getting exactly 2 successes out of those 10? Now, I wrote out the Q here. Q is 1 minus 1/3, which is 2/3. Which the Q is important if you're using the binomial formula, which I have here in purple. However, in either Excel or the calculator, you don't have to tell it Q, you just have to tell it P, because it will just do the 1 minus P internally in the formula. So you don't have to tell it that, so you only have to enter the X, N, and P. So I'm going to do it for this one. Now the input on these is a little bit different than the calculator, the order of them. Binom, dist. Okay, the number of successes goes first, whereas the number of successes goes second in the calculator. I don't know why. I would think M would go first here, but I would have programmed it that way, but that's not me. So 2 goes first, N was 10, 1/3. Now, this is either going to be true or false. If you're just true means cumulative, it would mean less than or equal to. And I'll talk more about that coming up. So 2, for if I put true here, it's going to add up 2 plus 1 plus 0 successes and add all 3 of those up. So I want false right now, because I'm only calculating, anytime I'm only calculating one value, I want false. Okay, let me do the formula text command here. Since now we're kind of back to using formulas that we really weren't in the last section. Okay. But the false means you're calculating a single X value. In the var, in the calculator. You go second, and you hit this vars button right here, because right above that vars in blue is the DISTR you see right there. So you hit second, vars, but it brings up the DISTR. We scroll down. Okay. Now, similar to Excel, they have a function here that does it for one value of X, and then they have it for doing less than or equal to that X. See, where Excel, they just separate it by doing true for, in other words, A here would be false. There's no true false in the calculator. It's just whether you pick binom PDF or you pick binom CDF. CDF would be the same thing as if I would have used true in that calculator. In fact, I'm going to go show you something in that other thing here in a second. Okay. But anyway, this is a PDF. It's asking for the input. It wants n, and it wants p second here. Then we have 2. Paste it, then it's going to show the command if you'd entered it in kind of the old way where you just put the numbers in the parentheses. Here, it lets you enter them into a fancy little screen and then dumps them into the formula. All right, I think we got a match here, didn't we? All right, let's see what we got here. Okay. That looks like a match. Now what I'm going to show you is I'm going to copy this. Well, it shouldn't change anything. I don't think it'll change any because there's no cell references there. Yeah, but I'm going to change the formula. I only want to change one number here. So this is so there. The line 2 there is if you would have said what's the probability of 1 success, and then line 3 is what's the probability you get no successes in those trials, that they're all failures. Okay, you'll see the reason why I'm doing this here in a second. Now I'm going to add these up, right? And where's my sum? There we go. Okay, let's keep an eye on boldface this. Then I'm going to come down here and I'm going to show you. Actually, I can copy this, be quicker. Copy both of these. I'm going to change this to true. You see what happened? That's what I was trying to explain. The difference between the two is the true adds up 2 and 1 and 0 automatically. So you see I did them individually here with false and then added the individual results, so it's the same thing. Now let me show you over here the calculator. If I go second vars, I'm not going to do the 0, the all 2, 2, 1, 0, all that for this one. I'm just going to show you the CDF. Okay, 10 trials. P is 1/3. And it's 2. So you see this binom CDF command was the same thing as the Excel putting the true in there. That the true is equivalent to the CDF. Now I'm not going to go back and do this, but obviously if I would have done the calculator, I could, you could do that and check yourself if you want to. You don't need to, but I could have done this binom PDF. I did it for 2. I could have done it for 1. I could have done it for 0. It would have produced these exact same 2 numbers right here, which then would have added up to be this, which equals the CDF. All right. So they kind of, there's 2 similar functions in there. Well, like I said, Excel just uses one function. It just uses the true or false to separate the cumulative. All right, for any binomial distribution, the sum, and that's true for any discrete distribution, the sum of all probabilities would add up to 1. So I'm just mentioning that idea, as we might be using that here a little bit, but it's the same thing from the basic idea of discrete distributions, the sum of all your probabilities, because the number of successes you can have is anywhere from 0 to however many trials in you have. So let me use a smaller number, so I don't have to say too many numbers here, but let's say you have 5 trials. The number of successes can be anywhere from 0, 1, 2, 3, 4, or 5. And all of those probabilities would add up to exactly 1. So let's look at this single die example here. And I may not retype all these in the calculator, because like I said, as always, we'll see real-time examples in Excel. I mean, in my stat lab of Excel and the calculator in my stat lab, but it'll be here for you to look at. So 20 times, that'll be your n. This time we're only considering a 5 to be a success. So that's a 1/6 probability. And of course, I wrote we don't need the Q for the technology, but it's there for the formula. I mean, you never know. You may have a question that asks you to identify what Q is as a test question like this. Identify N, P, and Q. So just make sure you know that, well, you can use your notes, but make sure you know that Q is 1 minus P. We don't need it for the technology. So here, I did binom PDF, 20, 16, comma 3. And got this 23.8. And you see over Excel here, I did binom dist, but the 3 goes first. It's just the order they want them. And then the 20, then the 16, and the false. But you can look at these as reference, and you can compare. That way, when you go to enter it, you'll see what's happening. And I'm sure you'll get used to it quick enough. And, I forgot to put the answer there. I guess some of these, but I wouldn't have just left it as a wrong answer. In other words, that means I must have looked and saw that the answer was right. That's why I didn't just, well, let me slap this in there and hope that it's right. No, it would have been right, or I would not have, or I would have changed it immediately. I already forgot what the numbers were. I know 1/6, 3 out of 20, 20 successes. 3 is 3 out of 20. Okay. Yep. 3 successes, 20 trials, probability 1/6, and I want false this time because I'm only doing one calculation. And I guess so when these notes are published, you'll now see, that's not what I wanted. Yeah, so we'll see that this is what it's going to look like. So, dang it. So I'll copy this in here. But when you see the notes, you won't see that. What's there now? All right, so where'd I? Because I could have just copied the number once I got it, but. Okay, where do I want to put this thing? I think what I'll do is I'll move this over. All right, I paused the video for a second because I didn't need to waste your time by just having you watching me cut and paste, move stuff around. Let's see. Well, I'm not going to pause for this because it takes long. Anyway, let's see what we got here. Got a multiple choice exam, 25 questions, and we're going to guess on every question. So the idea is, let's say, you're not even reading, in other words, we're not looking at as well. I can eliminate 2 of these answers, pure guessing. So it's almost like someone could, if they were handing you a Scantron form, you don't even need to see the questions, because the idea we're talking about is pure guess. You could just take a Scantron and just bubble it without even seeing the test, and that's essentially what we're doing here. Now, we have 25 questions, that's our N. Now, it says there's 4 choices for each question. So how do we turn that into a probability? Well, you think about it like this. There's 4 choices per question. The P, the lowercase p, is always the probability of success on one trial. So if you have 4 questions, you would have a 1 out of 4 chance of guessing any one question correctly. So there's where the 1/4 comes from. Now, if it phrased it in terms of like true false, it doesn't need to tell you how many choices, because true false is always 2 choices. But multiple choice has to tell you, because this could easily have been 5 choices for each question. So yeah, that there's no assumption with multiple choice like there is with true false that it's one or the other. You know, true false. That's it. We're going to guess, and of course I wrote the cue there. The probability of guessing 20 correctly. There it is in the Binomial PDF, scientific notation that times 10 to the negative 8. That means you start right there where that 1 is, the decimal, and you move it back 8 places. That leaves 7 zeros right in front of it. And that is an extremely low probability. You're kind of working your way into almost lottery land right there as far as guessing. Yeah, it's astronomically low that you could guess all 20 of those correctly. Now we're going to start getting into looking at the idea of answering our questions where it's not just a single value, where we have to use the cumulative, or we can use this thing, a binomial table. This is, when I show you this might be something you might want to use instead of the technology. Because if it's less than or equal to, it's easy because it'll be the cumulative. But if it's like greater than or equal to, it gets a little tricky. So this binomial table is going to be in D2L. It'll be in some folder there. Probably, charts in Excel, or whatever, because there's some Excel files we're going to be using in the 3rd unit, pre-programmed Excel files that I came up with. So now it's impossible to have a binomial table for every possible value of n and p, and this table only goes up to 20. So what I do on a test is just so you have this option. It may not be true on a homework, but on a test it can be, because I can keep the parameters of it, within that fit this table. I can make it be a numbers that fit on here. Now, because you're still going to have to know how to do single probabilities, just either using Excel or the calculator. This doesn't solve everything, but it's going to solve anything on a test that involves adding probabilities together. I will make sure it's something you can find off this chart. But then again, you could still choose not to use this chart. Okay, now this we got to kind of be careful when we're reading wording, and this will come up later in another chapter too, in the third unit. But I don't try to get too tricky, but we're not going to really need the differs right now. We will later, but at least means greater than or equal to. Fewer than, less than, that just means less than. No more than, at most, is less than or equal to, if it doesn't just say less than or equal to. More than, above, greater than are all the same thing. So it's not my goal here to kind of trick you, but we do have to be able to, read these things and turn it into the proper symbol to be able to get the proper probabilities. Now this little snippet is from the entire table. It's just so you see what it does. It has the ends here, and I think my table goes all the way through 20. N is 2, N is 3, all the way down to 20. And like I was saying earlier, your x's, whatever your n is, your x's are going to be all the way from 0 to whatever that n is. So 2, your x can be 0, 1, or 2. For 3, it can be 0, 1, 2, 3. So forth, so on. And then across the top row are different values for p. That's why it's impossible to make a table for every scenario. Let me give you an example. The rolling a die, the probability is 1 over 6, and if you make that a decimal, that's 0.166666 technically forever or whatever. I guess you could approximate it, I guess, and come up with a table value of 1.667 or whatever and stop it and put a 7 in there, but anyway, the point being is just too many other decimals you could have. But so we'll make sure that they work off of this for any problems where we're going to be adding stuff together. Now I'm going back to the guessing the multiple choice. Now, so suppose we have 20 questions with p equals 1/4 again. Find the probability of guessing no more than 4 correctly, and I said using the binomial tables, but I'll also show you the technology for this one because it is less than or equal to. That works good for the technology. But I'm going to show you all 3. So you have to be able to interpret that no more than 4 means less than or equal to 4. That's not the same thing as less than 4, because no more than 4 means we include the 4. So that gives me x values of 0, 1, 2, 3, 4. So if you're using this with just the regular, I didn't do this, but we're not using this formula anyway, but the idea is if we were, like I used to, you would have to do this 5 separate times and add them together, which, you know, can be done, but it's kind of tedious. So in other words, the same thing if you were using Binom PDF in the calculator, you would need to add 5 of them together. If you were using Binom DIST with false as the command, false, you would have to do that 5 times and add those together. But let me show you on the table. So you'd go down, I'll bring the table up for a second, but I got it. Go down here, 20 is the last one I have for the ends. And 1/4 converts to a probability, unlike the 1/6, like I was telling you for the die, 1/4 converts to 0.25, which is right off the table. Now you see when you look at this table though, on each page, the values are at the top of the page, but that's, you know, you can use a straight edge or anything, and you know, you can look down, but when I snipped it in the notes, I made it look like the probabilities were right above 20, but they're right up here. So it's this column right here. It's that column. It won't let me highlight that. No, it won't let me select it. Well, let me draw it. Okay, okay, so it's that column right there. And then we want 0, 1, 2, 3, 4. So it's all the way from there to here, right off the table, and then you would just add those numbers up. So I have it kind of cleaner looking right here. You see, so I got a box around all those 5 numbers. You would add those up, and you get 0.4148. So that's not bad. I'm not going to retype this one in there, even though it doesn't have the answer next to it, but the command it's correct. I'm using Binom dist. I'm using 4, 20, 1/4, but I'm using the true. The true means it will add up less than or equal to 4. Now the calculator, I showed you 2 things. Now I showed you the CDF, 20, I could have done the same thing with Excel, I guess. But anyway, I might go back, let's see. All right, I paused the video for a second to make a nice little edit for us here. I think I saw something I could make better, so I think I did. Now I got the Excel in there. Now let me show you then that the Excel, so for the true, it adds all of them up. But I want to show you and compare this to the table and also the calculator, same thing. Now false, so true means less than or equal to 4. False means just equal to 4. So check out this number right here, the 0.189 blah, 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 blah. That's the number right here at the very bottom, because that's a number for exactly 4 right there. But see, the true adds up 43210, boom, adds them all up. Same thing in the calculator. CDF doesn't use true and false, but CDF adds them all 4 up and gets this number right here. And then I must have hit enter twice here or whatever. That's okay. That's not 2 separate things, obviously, but PDF just gave me that x equals 4 number, the 1897 right there. So hopefully that's becoming a little more clear. All right. So let's see what we got here. Now you have to try to use the technology for this. You have to be pretty clever. I'll show you what I did down here. You know, you can do it, but yeah, I would strongly consider the chart on this one. And I'll explain what I did here. But if you're a little confused by that, that's okay. That's why I'm suggesting maybe the table's better for this one. So n equals 16. Probability of success on any one trial is 0.6. So we want to know n equals 16. Find the probability of more than 10 successes. All right. So the key is more than 10 means the same thing as greater than or equal to 11. So you would add up the bottom 6. Add those numbers up in the calculator and get your answer, and there you are. Looks like I didn't do the calculator, but I'll show it to you in the calculator, and at least if I do that, I'll paste it here also at the same time. And this is just what I was telling you about. For the problems that you have to add them up on, I'll make sure that they're on the tables. But anything else can be just a single value, can be any kind of probability. In fact, I don't want it to. For those, I don't want it to be one you can get off the table. I want it to be one that you use either Excel or the TI to get it. But for this, I want it to be something you can get off the table in case you don't like what I'm about to show you here. Now, this goes to the idea of that all the probabilities have to add up to 1. So all these probabilities have to add up to 1, which you don't have to verify that. Oh, by the way, these probabilities where they say zeros, that doesn't mean it's the exact number 0. It just means you don't start seeing any numbers till after the 4th decimal place at least. So I just wanted to mention that. But obviously, if you're adding those up in a calculator, you can ignore them because they're zeros. All right, here we go. So I got the little box around 11 through 16. Okay. Which means the part that's not in the box is 0 through 10. So we're going to use the idea of complements here on this. That means all that has to add up to 1. So that means the bottom part in the red box has to add up to 1, plus this other part has to add up to 1. Well, the other part is from 10 to 0. It's cumulative. It's cumulative probability. Oh, I did do it. Okay, I did do it in the calculator. I'm sorry. I did both the calculator and Excel. I just didn't show the answer in Excel, but I'm confident that it's right. So if you want to go knowing that they have to add up to 1 because they're complements of each other, 1 minus the CDF at 10 will leave you, by default, will leave you these right here, these 6 in the box. You see it gives you the 3288 right there. And then same thing here, 1 minus binom, but you have to use true, and you're still using the 10, the 16, and the 0.6. So I don't know how you feel about that. That's going to be up to you to feel any way you want about it. So I just because I said I just think maybe the table might be a little easier, but if you're determined to make it work like that, okay, that's up to you. Well, you know what? I'm going to change this. To make it more modern day here for my class, Excel. Let's look at this one real quick. Okay, blah, 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 blah. Fewer than 4. So that's the key wording here, fewer than 4. That's just less than 4, so it's 3, 2, 1, 0. It's a 3 of those. So that means you can get it from the chart right here. There's 6. There's 0, 1, 2, 3. You can add those 4 up, or you can just do a cumulative at 3. This time, it's don't do 1 minus here. 1 minus is whenever we wanted the greater than part. But for this, just do a straight up cumulative at 3. And you'll get the 9624, or binom CDF, because that's the cumulative at 3, and you'll get 9624. So, yeah. So the key is, the commands are nice there if you understand what to put in there. That's the key. For those cumulative ones, you have to be careful. Like I said, the last one we did was a 1 minus. Now, unlike the last section, this has a real nice formula for mean, variance, and standard deviation, and quick and easy. There's no built-in program in Excel or the calculator, but there doesn't need to be for this because it's no trouble. The mean is just n times p, and the standard variance is npq. Reminder once again, the q is 1 minus p. And standard deviation is always the square root of the variance. I know I sound like, keep saying that over and over, but that's because it's true. Like last section, we had a variance formula. Its standard deviation was the square root of that formula. Here's a new one, NPQ. Well, look at that. Standard deviation is the square root of NPQ. It's magical. (20-question multiple choice exam, 4 choices each. What is the mean number of successes? Expected number of successes. So this is where you have to realize that the probability is 1/4, like we talked about earlier. Because there's 4 choices. So read that carefully. It could be 5 choices, could be 3 choices. Doubt if it'd ever be more than 5, but so it's 20 times 1/4 equals 5. Now I'll explain to you what that means, although it's not going to ask you that on a test, or well, the variance and standard deviation I'm not really going to explain that much, but the mean means on average, like say basically kind of like the law of large numbers, but if you did this over and over and over, how many would you expect to guess right on average? Obviously, if you did this, you'll get one answer. Next time you get another answer. Every time, if you kept filling them out over and over, like Scantron forms at random, you get different results. So this mean tells you the expected number average of successes long term, which, you're not supposed to miss them all. You're supposed to get some of them right by guessing, but 5 out of 20 is not a very good test score, though, if it was of an exam, would it? So you're not supposed to miss them all, but it's not going to be very helpful to guess. Another way to think about this is if you have 4 choices for each question, and so you got a 1 in 4 of getting 1 correct, that means in theory, not in practice, but in theory, you should get every 4th question right. Well, if there's 20 questions, that's 5 blocks of 4. So you're thinking getting 1 right in each block of 4, and that would be 5 total. So you don't have to worry about thinking about that. I just wanted to mention to you what that meant. So this variance, just calculate it. 20 times 1/4 times Q, which is 1 minus 1/4, 3.75. Standard deviation, just square root of that. Here's another one. Same thing. Nothing too tricky there. I won't even worry about explaining that one, especially since it gives you the probability. Okay, here, let's look at this real quick. Not difficult. We just have to make sure we realize that the P is 1/6. So we're letting a 1 dot, a 1 facing up, be a success. So we roll it 30 times. 30 times 1/6 is 5. That means then 30 times we're expecting on average we would get a 1 5 times. But once again, that doesn't mean if you pull out a die, now and roll out 30 of them, doesn't mean you'll get 5 ones, but the average in the long term should be 5. So 30 times 1/6 times Q, which is 5/6, 4.167. Standard deviation would be the square root of That was 2.041. Got a couple more. I may not do all of these, but this one I like. It's kind of interesting. You have to read this one carefully. Probability we produce a defective item. So maybe we got some business, we're producing something, we got 0.05. That seems kind of high. Quality control might need to look into this, depends on what we're making here, but I'd like to have a lot lower chance of, buying an item in a store. Suppose I want to go buy a new tool, new power tool, and I'd like to have, lower chance of it being defective than 1 out of 20. But anyway, we take 15, so somebody's coming in and looking at our business, maybe corporate's coming in here. If more than 2 items are defective, the process will be shut down for maintenance. So we want to find the probability the process will not be shut down. So the best way to do this is to look at it as the not being shut down. So if more than 2 means shut down, that means 3 or more. 3 all the way to 15. So not be shut down would be 2 or less. So the opposite of 3 or more would be 2 or less. So if they come in and they find only 2, 1, or 0 defective, we're in good shape. We passed the test. And here it just says assume the conditions are binomial or met. It says you may use the binomial tables. You can use them anytime you want, obviously, but now let's see. So it's less than, once you establish less than or equal to 2, then we're in good shape. We can skip everything on this page. Just come down here. Now I use the table. 15, you got to find 0.05. I'm not saying 0.05 is in the first column, but I just cut it. Yeah, just for illustration purposes. Let's see. I think I can erase this. Okay, well actually yes, 0.05 is in the first column, but I could have just selected only that column. So you can get it from right here. You can just add up those 3 numbers for 2, 1, and 0 and get it that way. Just for the heck of it, I did 3 separate Binom PDFs without getting their individual results and just added them together. That worked. But if we realize how to use the CDF, because it's less than or equal to 2, I used the CDF at 2 and got that answer. Same answer as this. And you see those 3 added together from the table. That's the same answer. Well, a little bit off, but not enough to cause. That's because of the rounding on this table right here. That's why it's slightly off. Because there would really be more if I had, but I needed to get everything to fit on a page. So if I would have shown more decimal places on here and would have added, then it would have been, but it's still correct. And here's the binom dist. If you use true, that's the same as your CDF here. So 2, 15, 0.05 true. So the probability, I just rounded to 964. So in terms of percentages, we have a 96.4% chance that we will not be shut down. So that's pretty good. And here's the mean, variance, standard deviation. That's easy enough. I don't know. I'll leave these 2 in here. Okay, I got the calculator and I got the Excel there for this one. And yeah, this one's not as good in Excel because you can't really use, well, you can't really use the cumulative in either one of them. I'll just mention this real quick. I don't think I'd ask this on a test, but between 2 and 4. See, so between 2 and 4 is not the same thing as just less than or equal to 4. It's 2 plus 3 plus 4. So it would take 3 binom PDFs added together, or 3 binom dist with the false here. Remember, false is the same as binom PDF there. Add those 3, or specifically pick, I label, there's the 0.65. So obviously this is not the first column here. I just didn't want to spread the whole thing out and take up room. So that's showing you it's the 0.65 column. And add 2, 3, and 4 that way off that table, which that might be the best way to do it for this one. And all right, so I'm going to, what they call, leave the exercise to the reader here or whatever on this one. So it's a good example as reference or whatever, but just to save time, I'll go ahead and move on since we'll do homework here. preview. So once again, I'm going to try to pick access denied. All right, well, my stat lab had timed me out there, so I had to pause it while I logged back in again. Mean variance and standard deviation, I don't know. I don't think that's too bad, but obviously if you need help, let me know. But experiment, binomial experiment. Yeah, I guess you could say that. So that means 36% chance that surveyed said they were reducing the amount of vacation. So it doesn't appear to, be dependent upon anything. Okay. Now you can just pick it up. Success is random variable represents number of workers who are reducing the amount of vacation. Yeah, so see, success, it's not something you interpret as something meaning good or bad in the real world or whatever. Like a good example, one I didn't mention that before, but I should have mentioned it, like the defective product or whatever. We might think, well, how, why is sampling a defective considered to be a success? Because that's what you're trying to measure from a probability standpoint is the defectives. So whatever you're measuring is considered a success, whether it doesn't matter, if the feelings don't matter, like if it's oh, that's not a good thing, why is that a success? We don't look at it that way. So it's whatever you're trying to measure. All right, let me jump ahead. All right. I guess I'll return to it. What is n? No, okay, we moved on anyway. Let me leave the show completed up here just so I can see what all. Okay, that one's not bad. Yeah, this one, like I say, on a test, I always set it up to where I can use the table, but it may not be true here. In these probability questions in the homework. I sure do have a lot of mean, variance, and standard deviation questions on there. I'm going to go back and delete one of those. I only have 2 probability questions. All right. All right, I made a slight edit to the homework set here, and well, since this video is made before the semester started, it's okay to edit it. Yeah. Anyway, I took out one problem and added a problem, so still the same number of problems, 7. But all right, 26% college students, they use cards because of the rewards program. You select 10 students, and then find the probability that for the first one, it says exactly 2 out of those 10 say they use credit cards. So it's either Binom PDF for this one or the Excel. I can do them both real quick. PDF, 10, 0.26. You may get lucky that it has to be, well, at the end it has to be less than 20, but if, you know, they change these numbers around, but if one of those, like that percentage would have accidentally been 25%, you could have also got it off the table, but I wouldn't count on that though. And X value is 2. Paste. It wants thousandths, 3 decimal places. So I'm going to go 274. Got it. Now do Excel real quick. It's going to be a equals binom dist and number of successes is 2. 10 trials, 0.26. False. It's not cumulative. We only want that one value. There it is, 274. So that was correct there too. Greater than 2. Now I'm going to use Excel to sort of, for another reason here. So I'm going to put equals 1. To kind of give you a visual here. No, I guess it won't. It doesn't. It won't. I have to say equals D10 plus 1. Then I can drag it down. It'll like keep adding 1. But there could be other ways to make it work. You know, a lot of times there's more than one way to do things in Excel. Little things. So, all right, I just want you to see that. So let me go back and look at the question. More than 2, we can't use the chart. Because like I say on a test, I can control what that probability answer is going to be. Oh, another video is ready. Okay. All right. I can control it on a test. I can't control it here. So, okay, now let's go back to what I was looking at. All right. Let's just give it some sort of non-obtrusive color there. There we go. So more than 2 represents that block of numbers, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry, also, excuse me. Let me add the 0 up in there. Okay, yeah. 0. But still, more than 2 is still that same colorful section. But I forgot, remember, it's always 0 through n. 0 through, in this case, 10. So it's either do 3, 4, 5, 6, 7, 8, 9, 10, binom PDF, or distribution false, and add those all up. That doesn't sound like much fun to me. So I'm going to use the complement idea. Let's give this a cute little color here. I'm thinking light blue or some sort of blue. There we go. So the blue plus the beige all adds up to 1. And the blue part would be cumulative. So I can go, if I go 1 minus the blue part, that's going to leave me the part that I want. So let's, I'm going to copy a cumulative here, because that way it's already set up to be true here. Well, I got to do 1 minus, so 1 minus, and then my values are 2, and it was 10.26, and I want that to be true, because I want to be subtracting the 2, 1, 0. So of course we'll make sure that this is right, but then obviously you can pause the video to look at this when you're doing one. Well, let's see if that's right. If it's 3 decimal places, let's try 504. Wonderful. And I haven't forgot the calculator. Calculator, you'll go, we went 1 minus true there, we'll go 1 minus binom CDF here. Got to scroll down to get to these. It's binom CDF, and it was 10 trials, 2 successes. No, P is next, I'm sorry. But it is 2 successes, but 0.26. Now the X value is 2. Ta-da! Look at that. 0.504. Now this one, I could show you. I could show you a trick on this one. I don't know if the trick makes it any easier than just doing 2, 3, 4, 5 and adding them together. So you could do a binom PDF 2, 3, 4, 5 and add them, or a binom dist false and add up 2, 3, 4, 5. But there is a way you could do it. Let me copy these. Let me just get these. Yeah. I need the no fill. We'll copy these again. Because I need 2 columns to illustrate this. Oh, well, let me do, okay, I messed up. I hit copy again instead of paste. All right, so now we're going to use our visualization skills here again. Oh, I have no fill. That's why I took the fill away. It doesn't really matter what color I use here. So I don't know if you're going to find this exciting or not. You might want to say, well, I'm doing all this to explain the logic behind it. You don't have to actually do this if you understand it, then you're doing the calculation. But if you say, no, I'll just do 2, 3, 4, 5 and add them up. But look at these side by side. Here's the point I want to make. So would you agree that the blue part minus whatever kind of reddish color that is, you see the blue part minus the red part? I could give this another color, but I want to make that more confusing. That would leave you the 2, 3, 4, 5. This blue one minus that red one leaves you these. So if you did a cumulative at 5 minus a cumulative at 1, it would leave you, oh, all right. I want to just show you this. You may already not be a fan of this, and that's fine. But I can say that I tried. 5 successes. Okay, yeah. Well, where's the other? Okay. Minus binom dist. I can't even see the keyboard. There we go. One. It's cumulative at 1 now. 10.26. And then true there. because we want both these to be cumulative. So let's see what happens. Then I think I'll show you the individual ones real quick. So same thing, well, let's see if this is right. I'm jumping ahead of myself. Let's make sure we get the happy little check mark. 0.734 around it, I think. All right, I think I looked at that number wrong. 754. I knew something but did not feel right about that when I said it. And you were probably yelling at me through the screen, I'll bet. It's 754. Unfortunately, I didn't hear you. There we go. But you could do the same thing with binom CDF at 5 minus binom CDF at 1. But if you want to, you know, this might be a quick way to, I just thought about this. This might be a more efficient way to do a repeated bunch of binoms. Let's see if this works. Put in 2. God, what's wrong with me? 4, 5. And I'm going to try using a cell reference in the command. So I'm going to go, let's put it down here. Well, no, I'll do it here. That way I can copy the formula. Equals binom dist I'm going to use the cell reference. So the number of successes then will be A19 in this case. A19, 10, 0.26, false. And if this goes the way I hope it goes, Doe did not like it. It might have, oh, that's a typo there. Stupid comma, okay. Maybe it'll like it now. Hey, okay, that was it. I just had a comma, so it'd be beautiful. So if I copy this down, let's see what happens. I'm hoping it'll change the A19 to A, you know, and take all those numbers with it. It did. So you see that one's got, that formula's got, oh, I should, I need to create another column here, so you can see the formula text. Let's go copy this function over here. And then I'll drag this down. You see, so it's doing A19. Yeah, so you can do it instead of typing them. If you type them once and then copy the formula, then you can come down here and do a sum. You can sum them up with this thing right here. And there's your 754. So that might be a little quicker than doing them at individual numbers and then adding them up. I think it is a little quicker. So say you just type the thing in once and do a cell reference. Wasn't that fun? Should probably do one of these. Let me see. Let me just check one of these next two. I skipped over. Actually, I deleted that first mean variance standard deviation. I got another one here. I'll do one of the ones at the end. Okay, let's. Wait, do I have the exact same question in there twice? No, but it's very similar, isn't it? It's the same x's. Well, this may get edited in the homework by the time you see it, so I'm just going to skip that one. That one may be gone. I don't mind the question. It's just I don't like the same. Yeah, I need new. If I can find fresh x values. All right, so that problem might get replaced before you get into the homework here. Okay, we'll do this one, and we'll call it quits for today. Oh, let me undo this. "73% of adults in a certain country believe that life on other planets is plausible. You randomly select 5 adults and ask them whether they believe in life on other planets." Okay, so just going to use the and just going to use Excel. I can do a calculator. we're just going to use Excel as a calculator. We're not using a specific function. In other words, this one I'm just doing n times p. So it's 5, and the same thing you do in the calculator. In the Excel, you would just do equal. You have to go equal 5 times 0.73. So let's see if 3.65 is correct. Ta-da! Variance is NPQ. Now you can do this a couple ways. I can go second enter, and you can either figure out what 1 minus 0.173 is, or you don't have to figure it out. Just put it directly in here as 1 minus 0.73. It'll take care of it for you. That's your Q. So there's NPQ right there. Let's try once 2 decimal places. So let's try 0.99. Well done. And then in Excel, you could use the SQRT command for square root. Here, you can just put second square root 0.9855. 99 again. Yeah, because that number's so close to 1, I'm not surprised. Because the square root of 1 is 1, so I'm not surprised they'd be the same thing. Got it. All right, so that's, okay, we go on average, that means the mean. So we'll put in 3.65. Differ not by no more than the standard deviation, which is 0.99. Excellent. All right, so with that, we will conclude this video on the binomial distribution.